Hello and welcome to the Amazon Web Services Partner Webinar Series. Our topic today features Move Your Oracle eBusiness Suite Disaster Recovery Site onto AWS. I'm your host, Sherry Sullivan, and your moderator. I'm with the Partner Marketing team here in Seattle, and we'd like to welcome you to today's webcast. I'd like to start with just a couple housekeeping items before we get going here. I'd like to remind you that we are recording today's session, and I invite you to submit any questions that you might have using the Q&A in your browser. I'd also like to let you know that we will make today's presentation available. We post our content on SlideShare as well as YouTube, and you can find our content available there post-event. We've got a great topic for you today. I'm pleased to be joined by Thuru Sadagapan, who leads the Enterprise Architecture Consulting at Apps Associates, which is one of our AWS consulting partners, as well as Bruce Burns, who's the Senior Business Development Manager here with Amazon Web Services. They both bring a wealth of expertise and specific to Oracle on AWS. The key focus areas for us today will be an overview of our benefits on AWS as well as Oracle, Test Drive Labs, and Apps Associates will share some Oracle application architecture as well as DR considerations and a customer use case. So without further delay, I'd like to introduce you to Bruce Burns. Go ahead and take it away, Bruce.
All right, thank you, Sherry. Appreciate that. It's my pleasure to be able to be here with you today. I'd like to talk a little bit about cloud to start off with. We're seeing cloud computing now as a more modern way of running IT systems. The cloud helps companies of all sizes become more agile. So instead of running your applications on your own server farms, you can run them on the cloud where IT infrastructure is offered as a service, like a utility. As an analogy, about 150 years ago, companies were buying their own power generators to generate electricity for their manufacturing plants and for their businesses. But over time, they moved to using electricity supplied by utilities, because it was cheaper, faster, and easier, a much more agile way to supply power that businesses needed. Now, at the start of the 21st century, companies are still running their own IT infrastructure, but we're seeing a move of this infrastructure to move towards the cloud as a service. Because through the cloud, we can provide it cheaper, faster, and easier, a more agile way of supplying the computing power that companies need to run their business. With AWS, your company saves money. There's no sunk capital costs or capital expenses to buy the hardware for projects. The massive scale and fast pace of innovation of the cloud drives the cost down for you with AWS. And with AWS, you only pay for what you use, just like electricity. So if you turn the power off at night, you don't pay for that electricity. And you turn your servers off at night, which you can do programmatically, you don't pay for that infrastructure while you're not using it. And the nice part is you can get the exact server infrastructure that you want instantly through AWS. Now, the cloud can help your company save time and improve agility. It's faster to get started. You can build new environments in minutes, not months, as you don't need to wait for new servers to go through the procurement cycles to take delivery and then rack and stack and go through the install, patch, and configure process just to launch an application. Today, using JSON code with our CloudFormation framework, you can consistently launch pre-configured compute, network, and storage stacks with just a click of a mouse. The elastic nature of the cloud makes it easy then to scale that up or down as needed in real time. So at the end of the day, you have more resources left for innovation, which allows you to focus on projects that can positively impact your business, like building and deploying business apps such as eBusiness Suite. This is a quote from one of our customers, the CTO at Playfish. With the high growth nature of our business, we're looking for a cloud solution to enable us to scale fast. Think twice before buying your next server. Cloud computing is the way forward. According to a recent study by IDC, companies can save 70% on their infrastructure costs simply by using AWS. That's a powerful economic driver in this age of increased global competition. IDC interviewed 11 organizations that use AWS in an effort to understand the long-term economic implications of moving their workloads over to the cloud. And as part of the study, they also looked for changes in developer productivity and agility from the business side, as well as the ability to deliver new apps that could be attributed to AWS. In summary, the 5-year TCO of developing, deploying, and managing critical applications on AWS represents a 70% savings compared to trying to deploy them on-prem or in a hosted environment. Our customers run and measured both steady state and variable state workloads. They rank these workloads as very critical to their business, 4.5 out of 5. In addition to cost savings, they're also able to increase their business agility and brought their applications to production far more quickly. To give you a sense of scale for AWS now, every day, 365 days a year, AWS adds the same amount of IT infrastructure to AWS as was used by Amazon.com in 2003 to run our global operations for what was then a $5.2 billion online retail business with 7,800 employees. So that every day we add that much compute, storage, and network infrastructure to AWS to keep ahead of customer demand. That economy of scale helps us to drive prices lower. We've had 26 price drops for AWS since we launched, averaging 1 price drop per quarter. AWS serves hundreds of thousands of customers in more than 190 countries today, ranging from the majority of new startups to a wide selection of Fortune 500 companies. Because AWS saves time, money, and removes friction from using IT applications, we've enjoyed rapid customer growth and adoption with our customers. Examining AWS, you'll see the same security isolations that are employed as would be found in a traditional data center. These include physical data center security, separation of the network, isolation of the server hardware, and isolation of storage. AWS customers have control over their data. They own their data, not us. They can encrypt their data at rest and in motion, just as they would in their own data center. AWS provides the same familiar approaches to security that companies have been using for decades. Importantly, it does this while also allowing for the flexibility and low cost of cloud computing. There is nothing inherently at odds about providing on-demand server infrastructure while also providing the security isolation companies have been accustomed to in their existing privately owned environments. AWS is secure. It's a durable technology platform with industry-recognized certifications and audits, such as PCI DSS Level 1, ISO 27001, FISMA Moderate, HIPAA, SOC 1, Type 2. These certifications are expensive to go through and they're very complex. But because AWS can do this once and spread the cost over all of the customers, all customers can enjoy knowing that they have the secure environment that a large company such as Amazon can provide. Our services and data centers have multiple layers of operational and security designed to protect the integrity and safety of the data. You can find out more by visiting aws.amazon.com/security. Now, for physical security, Amazon has for 18 years been experienced in designing, constructing, and operating these large-scale data centers. This is hard work, and it took us a long time to be able to build out this expertise. AWS's infrastructure is housed in Amazon-controlled facilities throughout the world. Only those within Amazon who have a legitimate business need to have such information actually knows the location of the data centers. And the data centers themselves are secured with a variety of physical barriers to prevent unauthorized access. Each of these services within the AWS cloud is architected to be secure and contains a number of capabilities that restrict unauthorized access or usage without sacrificing the flexibilities that customers demand. There's an interesting quote from Jim Warren. He's the CIO of the Federal Recovery, Accountability, and Transparency Board. His quote is, "In essence, the security system of AWS's platform has been added to our existing security systems. We now have a security posture consistent with that of a multi-billion-dollar company." Good. Large enterprises are running AWS for many use cases, including disaster recovery sites for building apps such as eBusiness Suite, running enterprise ERP and CRM applications in production, for backup, disaster recovery, development, testing, and training. Applications such as enterprise apps such as eBusiness Suite, PeopleSoft, JD Edwards, Siebel, and Hyperion from Oracle, as well as apps from other big vendors such as SAP, IBM, N4, and Microsoft. Customers are leveraging AWS for big data processing tasks around big data, including business intelligence such as OBI, business analytics. Other use cases include high-performance computing workloads for business insight, medical imaging, genome sequencing, human or web analytics, and business intelligence fields. A couple examples that I'd like to call out are NASA and JPL use AWS in order to get data out from their Mars rover Explorer, as well as the Human Genome Project. Both of these large projects are running on AWS. Other use cases for using AWS is creating and running internal line of business applications that we see enterprises doing to support the needs of internal functions such as HR and finance, and then developing customer web-facing applications to power e-commerce, mobile, gaming, and social media marketing sites. Those are some of the typical use cases. Okay, so what I'd like to do now is talk a little bit about the relationship with AWS and Oracle. 18 years ago, Amazon.com started building out our retail sites using Oracle technology. So Amazon is a customer of Oracle first. And we work with Oracle very early on and still do in being in their beta programs, their customer advisory boards, and all sorts of different ways to ensure that the new features that we need to power Amazon are incorporated in the new versions of the Oracle software. So we have a very close relationship with Oracle as a customer. Now, when we launched AWS in 2007, Oracle was one of the very first companies to come out to support AWS. And they supported running their database as well as middleware and their operating system and management stack on AWS since 2007. And then in 2010, we expanded our relationship and added on Oracle applications as well. So eBusiness Suite and JD Edwards, Siebel, etc. All applications are certified to run on AWS. So very good long-running relationship with Oracle. On the subject of licensing, we make it very easy, and basically we have license mobility for Oracle licenses. So if you're using ELAs or ULAs or even the BPO program, you can move those licenses from on-prem to run on AWS. So the same way that you would license an on-prem server is exactly how you license it on AWS. We use the same core multipliers, so for standard edition licenses, for every 4 processors you require 1 license, and for enterprise edition it's for every 2 you need 1 license. For more details, there is a URL on this slide to find out more, or you can just Google Oracle Cloud Licensing for more information. Okay. Now, one of the things that we've done is worked with to create something called the Oracle Test Drive Program. And Oracle Test Drive Program allows us to work with companies such as Apps Associates and Oracle to be able to instantly launch complete stacks of software, in this case, say eBusiness Suite or Disaster Recovery Stack, and instantly launch them off the internet so that you can try and use these yourself for free. And it typically takes around 15 minutes once you say launch to launch an entire stack. We then provide you with admin rights to be able to log in and actually use eBusiness Suite for yourself. Apps Associates has been one of the early pioneers in this, and today we have 4 labs that are up and running on AWS from Apps Associates, such that you can deploy an Oracle stack in minutes versus months and then use that for evaluation. Oracle's own sales team has used AWS, and what they've told us is they've been able to decrease the amount of time needed for evaluations of their software by 33%. So what's nice is you don't have to wait around for the hardware to come. You can just log in and start using and evaluating the software right off the bat, instantly launching it, trying it for free. Apps has eBusiness Suite and a disaster recovery site. They're also building out a new lab that will be able to bring these 2 things together. So with that, what I'd like to do is turn it over now to Dhruv from Apps Associates to continue this webinar. Thank you.
Thank you, Bruce. Good morning, good afternoon, everyone. This is Dhruv Saragopan with Apps Associates. I am working primarily with the Infrastructure Services Group within Apps Associates, where we're providing DBA and cloud-hosted services around Oracle technologies. Today, I'm here to join Bruce and Amazon Web Services to talk about how we can deploy very effective disaster recovery solutions for Oracle eBusiness on the AWS platform. A quick introduction of Apps Associates. As you can see on the left side, the company was founded in 2002 with the simple principle that there's got to be a better way. And we have stayed true to that over the last 10 years and celebrated our anniversary last year. And we are a global provider of business and technology services around Oracle technologies. As you can see on the left side, our focus remains pretty strong with eBusiness Suite from version 11i or 12 through Fusion applications, Oracle Business Intelligence, and the various business analytics products around various data sources such as eBusiness and PeopleSoft and JD Edwards and other ERP solutions. Strong focus on Fusion middleware as well, along with the infrastructure and cloud-hosted services. So with that introduction, let me move on to what we're going to talk about today specifically. Want to open up with a quick review of the eBusiness Suite architecture and the typical DR considerations for Oracle eBusiness, and look at some sample DR architectures that we see in the market today, and then see how does AWS Platform help in this regard. How do we leverage AWS Platform disaster recovery solutions? And I want to end this with a quick review of what Bruce introduced just a few minutes ago about this test drive labs or try it now labs, and how we have access to actually launch your own environment and work with it through the AWS website. And finish with the introduction for a trial offer we have for customers who are interested in exploring the disaster recovery solutions for AWS. So this is a slide that I'm sure many of you have seen before working with Oracle eBusiness. Sort of depicts the three-tier architecture with the database on the right-hand side, 11G, predominantly used today as a database platform. In the middle, you have your application services tier running on the 10G application server stack, where forms, reports, concurrent manager, various services related to eBusiness Suite are typically handled from. And the third architecture is your typical web layer of your web browser with the Java applet that is running, and how you are accessing the eBusiness Suite. The next slide here, I'm showing a couple of typical deployments. Here, a corporate data center. You would have one or more database servers, and once again, one or more application servers, depending on the concurrency and the workload that you require. Quite often, there's a load balancer if you have multiple application tiers on the eBusiness Suite. And sometimes we also find external public-facing eBusiness modules, such as iRecruitment or iSupplier, or any of those modules that are customer-facing. If you're already deploying on Amazon Web Services platform, a typical eBusiness Suite infrastructure deployment would look like this. Again, a database layer with its data volumes, and one or more application servers with elastic load balancer in front of them, and that is able to serve your internal user population organizations. What are some of the typical disaster recovery considerations for Oracle eBusiness Suite, or for that matter, any business critical applications? All of us have heard the terms RTO, RPOs, essentially, right? The RTO stands for how much time to be able to recover and be up and running on the DR side, and the RPO typically indicates the amount of data loss that, from SLA perspective, that this particular solution can tolerate or it meets in terms of an SLA. That's often a very important consideration that defines and drives the disaster recovery architecture that is being deployed eventually. The geography is an important consideration. Where are the organization's users distributed globally within the country, North America? And what are the connectivity requirements between your physical system, physical environment, and the primary environment, and in the disaster recovery environment? And how are users going to access the disaster recovery side? How much network capacity would be required between the primary and the disaster recovery systems for the various synchronization activities that have to be performed. And then deployment and testing of the whole solution. Complete documentation of what are the steps to maintain it, and as well as recover and bring the DR system up and running. And these considerations, of course, in the context of our discussions today, has to be focused on Oracle eBusiness Suite, the database data, and application state data. And of course, no disaster recovery solution is complete without also talking about how are we going to fall back to the primary. Failover is important. At the same time, what is it going to entail to be able to come back and operate on the primary if we do have a situation for failing over to the disaster recovery side. Now, how do organizations typically handle these disaster recovery environments? So in this slide, I'm illustrating essentially at the primary site where your production environment is running, and a disaster recovery site that is distant geographically, hopefully. And the databases, commonly attached to a SAN. There is some sort of a daily backup, either to backup media, to disks, and there's often a media involved, the backup tapes being stored within the library, and often there is an offsite process to make sure that the backup data on tapes or disks are either replicated or tapes are physically being shifted to a vaulted site. Now, this is commonly found in every places, but often we also see that this is in fact also the disaster recovery plan, in that if the primary center were to go down, the disaster recovery plan for an organization could be to retrieve those tapes that are safe in a vaulted site and bring up or procure additional servers and build and deploy or build your eBusiness environment off of those tapes. Now, these kinds of solutions, obviously, depending on the time it's going to take to recover or the frequency at which these tapes go off-site. If they go daily, then you're looking at 24-day data loss or maybe 48-hour data loss. Or if the tapes are going once a week or once a month, then there's even a larger data loss into the framework, into this picture for a solution such as this. Now, many organizations also leverage the DataGuard technology, wherein they're able to create a copy of their production database in a disaster recovery site, as I'm showing here on this slide, and then use the DataGuard facility of shipping database transaction logs. In Oracle terminology, they're essentially the redo archived redo logs that are being shipped, and they are keeping the standby environment in sync with the primary environment. Now, this technology allows, of course, of being able to achieve much tighter RTO and RPO objectives. Typically, we are able to look at 30 minutes or less of data loss, recovery point objective, and able to bring up the eBusiness environment at the disaster recovery site in less than 2 hours or so. Many companies often perform 2 tests per year as well. There are also several use cases of customers not necessarily using, say, the database the DataGuard technology for synchronizing. Some SAN-based technology is also leveraged, where the SAN in the primary data center is synchronizing with a SAN in the disaster recovery data center, and then the servers that are available to recover and build the data off of the SAN synchronization activity. Both of these work very well, and are widely used at several enterprises for dealing with Oracle databases, and specifically Oracle eBusiness Suite. Now, with that bit of an introduction, right, let's see how does AWS help in this regard. How can we leverage the AWS platform for the disaster recovery considerations? Let's look at the geographical requirement that we talked about earlier in terms of the distribution of users and also the distance between the primary and the disaster recovery systems. The AWS Global Infrastructure has multiple regions. There are 3 regions in North America alone, and there are several more, as you can see in this diagram, across the world. And each of these regions have multiple availability zones in terms of being able to provide various organizations around the world to be able to build a DR environment in any of these regions and any of these availability zones. And there are different connectivity options that are available. If you're, as your primary environments are running in your corporate data centers, you can connect to your DR environment at any one of the AWS regions by several options. A site-to-site VPN connection is quite commonly used. And you also have the option of having direct connect if you like to have dedicated lines, MPLS or lease lines brought directly to your AWS region. That is, it gives many customers the ability to have a disaster recovery environment at the appropriate geographical location that gives you the geographical disaster recovery payload you're looking for and a robust platform and connectivity options for synchronization. Let's look at this diagram here where I'm showing what a typical DR environment could look like deployed on the AWS region and AWS infrastructure on the right-hand side, and the corporate data center, which will continue to have the primary disaster recovery environment, and that is depicted on the left-hand side. On the box on the left-hand side, the corporate data center, I'm showing the database tier, and I'm also showing the eBusiness application tier. For simplicity's sake, although there could be rack cluster databases and load-balanced application servers, for simplicity for this discussion, I'm essentially showing one database server and one application server in the corporate area. On the right-hand side, we're depicting one server, which we're calling the standby database server, and it has essentially the data volumes, all the storage that is required to support your primary database environment, eBusiness database. And it also shows the application volume that is going to support various Apple Top and Common Top and all of the different files that are required to run the Oracle application binaries and any customizations that you might have. During the normal course, the customers, organizations, the users that are depicted on the top are accessing the primary corporate data center where your production eBusiness systems are running, and they have the option of connecting to the AWS disaster recovery site. This is showing a scaled down standby. The reason why we're calling it a scaled down standby is that it's just showing one database server. It could also be a server that is probably running with 1 or 2 cores of CPUs, just enough to maintain a standby environment and synchronize with production and apply the archive redo logs as they're coming to keep the standby database environment in synchronization. The assumption here is that we're leveraging the data guard feature of the Oracle database to keep and maintain a physical standby. And we're also able to synchronize the application files as required using rsync or any other utility that may be available in your native operating system to synchronize again to the DR environment in the AWS region of your choice. Now, when there is a failure of some sort that causes the loss of your primary production environment, we activate the DR site. The DBAs will go through the normal motions of recovering and bringing up standby database and doing what is necessary on the application tier with auto configs and things like that to bring up the application tier. We went now from a scaled down standby into what we now call a scaled up production servers. As you see that we are now showing an application tier as well, but what you also have the ability to do here is to bring up a much beefier database server. What may have been a 1 or 2 core database server just for synchronizing and running a standby environment is now 4 cores, 8 cores, 16 cores that is required to handle your production workload. It doesn't have to be a smaller environment that typically DR environment tends to be. DR environments are often expensive to maintain and they're not necessarily built to handle the full production capacity. Many DR environments are architected to handle mission critical activity and they're not necessarily the full capacity of the production environment. However, in this dynamic, flexible, on-demand capabilities of obtaining CPUs and memory as required on the AWS Infrastructure as a Services platform, we are able to bring down that small database environment that was running as a standby and bring up a much larger database environment and a large application environment, one or many as it's required. And of course, all of this is built and tested and documented so that when disaster does strike, or if there's such a simple test that you're performing on a yearly or biannual basis, we're able to execute these things as documented procedures. With this, now the users have the capacity or the ability to have a much better experience and it allows the organization to have much simpler infrastructure, agile, flexible, and available at a much reduced cost. On this slide, next slide here, I'm summarizing some of the advantages of the AWS platform that I just described. First and foremost, we start off with the minimal infrastructure. It's a reduced footprint, one server with minimal cores, as we talked about. Storage, of course, we will allocate the storage that is required to run the full eBusiness, whether you're running a database with a few hundred gigabytes or you have a database of multiple terabytes. We have the storage allocated to the standby environment so that it has the ability to run your full database environment in the standby mode and eventually production. Certainly the network infrastructure that would be required to synchronize your primary environment with your DR environment would be in place right from the beginning, as required to keep logs synchronized and also for users to connect and access the DR environment. The on-demand resources, we can allocate resources as and when required, whether it is testing or a true failover to bring up your DR environment. We don't have to compromise on the disaster recovery investment with this type of a solution, so that we have the capacity to handle production when we do really need it on the DR side. One of the effects or side effects, if you will, of this kind of an architecture is that it also provides some relief for organizations for licensing considerations, in that your DR site is now running with minimal number of cores, and when we do bring up the full production capacity on the DR side, the production capacity is shut down on the primary side. So therefore, you're running your full production load on only one data center at any point in time. Significantly low investment costs, combining all of these features together across your physical infrastructure, meaning the buildings and whatnot. We are leveraging a hosted solution with all of the security credentials that Bruce highlighted earlier that stands up to all of the various regulations and compliance requirements that many organizations face today. Systems infrastructure, servers, storage, networks, virtual private clouds, and the security and the network hardening that is required to run your operations are available within the AWS infrastructure for you to design and build. And it's also available at a very low cost. And most importantly, this entire solution comes to you with no long-term contractual commitments that we often see with traditional hosted environments, or if you're purchasing your own equipment, essentially we're coming into the long term of the one-time upfront purchase of a CapEx commitment here. So this comes with no contractual commitments. You're able to run and operate as long as you want, as short a time frame as required, based on your business requirements or changing climates within the enterprise. Now that we've looked at DR and what AWS Platform can do for customers leveraging Oracle eBusiness, let's look at what more can we do. If you do have this DR environment in place, what I'm now showing is the same as what we saw before, the corporate data center on the left, and the Amazon region that you have chosen for your disaster recovery site, where the standby environment is running. It's that same small database server configuration. It has the data volume and the application volume, and it's being synchronized continuously by the archive redo log files in rsync. Now that you have a DR environment running in the AWS region, it now offers every organization the capability to launch test dev environments on the fly. It can take 10 to 15 minutes to launch a server environment or multiple server environments. It could also be pre-imaged with all of the RPMs and configurations that eBusiness requires. It doesn't have to be a fresh install of Red Hat or Oracle Enterprise Linux or any other operating systems you may have. It could be a pre-imaged environment up and running, and by using the database that is sitting right there and restoring as RMAN from your DR environment, you can build your eBusiness environment and use the same application software that is sitting there and wrap it alone to build the application layer. This gives very fast, very quick access to new hardware and the ability to bring up test dev environments very quickly, less than 24 hours in most cases. The time depends totally on the size of your database in this instance, and the documented procedures for DBAs to build. So these are copies of your production, synchronized continuously. So the data that is going to be in a test dev environments are going to be production data to less than 30 minutes old. And you can, of course, go through your normal cloning procedures, the post-clone data cleansing, and various aspects of this that you could, you could leverage in building these environments. And no contractual commitments. This could be a system that you leverage for perhaps 1 week or 1 month, or run it for 2 weeks and some delays in the project, and we shut it down. We don't pay for the AWS infrastructure for CPU and computing cycles when the systems are shut down. The storage, of course, is already provisioned. It is small, minimal cost, and you have the capability to restart those test and dev environments a few weeks down the road. Very powerful use case there. Taking that same example further, we can now look at having one corporate data center feeding multiple regions for global enterprises across the world to provide various test dev environments at some AWS region that is closest to them. Or it can be used for various workloads. You could have a data guard fed reporting environment that could be used to offload reporting from your primary environment for Noetics, or you could be using your standby environment as a source for OBIE, especially with 11GR2 features of flashback, or even Active Data Guard. You're now able to not have to recreate your disaster recovery environment as a copy of production just because you opened it up for read and write. We have the ability to keep it open continuously with Active Data Guard, or use the flashback technology to open it up for reporting and then bring it down at night for resynchronization and open it back up for reporting again in the morning. Several interesting solutions open up as a result of this readily available hardware platform. It's a quick case study of a customer that we worked with recently, headquartered in Japan, and they have North American operations in United States and Canada. And we started off with a quick assessment of the environment. They're running Oracle Business Suite, BI, and several other business applications. And like any other organization, several other back office applications on Microsoft and Windows and various technologies. As associates worked with them, we started off with a quick assessment and identifying the best suited workloads for deploying, what is ideal for deploying on cloud platform. And the customer chose to work with the Amazon Web Services platform. We proceeded further with the proof of value to demonstrate what it would look like, what the response times will be, and how the systems will run. And with the success of the proof of value, the customer decided to move ahead and run all of their Oracle solutions and pretty much the entire back office applications on the AWS Cloud. And we helped to manage and take them there, and now are also helping administer and manage this environment day to day on a 24/7 basis. This diagram depicts what this customer's AWS region looks like. What you see on the top is a private subnet where all of the business applications are running, as you can see, OBIE, EBS, Lacrosse, and various Windows applications. They also have a public subnet where they needed to run some public-facing applications. For example, our domain controller, they were using Office 360 for synchronization for their email exchange, and there was a Salesforce.com application where login was integrated with Active Directory, and there was again a public access that was required. Essentially, it opens up to all those various integrations that are required with proper security and hardened server environments under consideration. We're showing the various locations on the top right, connected by site-to-site VPN tunnels directly from each location to the AWS region. And the Apps Associates team are also connected by a site-to-site VPN tunnel into this environment to help manage and administer their now remote corporate infrastructure, data center infrastructure on the AWS platform. And they're also leveraging DR in another region of AWS for the Oracle eBusiness alone. They're only running DR for Oracle eBusiness, and they don't have a DR environment for the other applications based on their choice of SLAs to the business. I want to take a few moments now to introduce the labs that are available. Bruce mentioned earlier about these test drive labs that you can access through the Amazon Web Services pages. If you search for Oracle or test drive labs, you will find them. And several partners have worked with Amazon to provide various self-service labs here. Here I'm showing the labs that Apps Associates has built. As you navigate to an Apps Associates-based lab, you will come to this website, or you can come here directly. Allows you to register and provide an email address where details about the various labs will be sent. These labs essentially are totally self-service. It allows any user to come in and launch a stack of database servers, application servers, and complete step-by-step tutorial of the environment that is configured, and a guide as to the users as to how they can go about exploring the features of that specific lab. Whether it is interested to see how eBusiness Suite runs in the cloud, or you're interested to see a pre-built OBIE environment eBusiness data source that's prepackaged in a data warehouse and experience OBIE analytics, or you want to work with the disaster recovery for a database. This disaster recovery lab, as you see here, is essentially focused around the database and how we can work with running a standby database environment and failover there. It also talks about the Oracle Secure Backup, which is a powerful product that Oracle and Amazon have jointly developed. It's integrated with RMAN, and it provides users the ability to do a backup for their database, Oracle database, directly to the Amazon S3 cloud with proper consideration for security, encrypted on the fly, and you're directly getting a remote off-site backup location for your environment. This is the quick summary of the labs that you would get when you do login, and you're able to click on any of these and launch and experience that lab. Each person gets their own set of servers and environment and step-by-step tutorials to guide them through their experience of exploring the functions and functionalities and features of the specific lab environment. So I want to end the presentation from my side with this offer to all of you listening and to the customers who are interested in this down the road. Essentially a complimentary workshop that we are offering to our customers where we would work with you and provide you access to a DR environment for a Vision database environment, and also provide how-to analysis to help and understand what you might require for your specific eBusiness platform in terms of being able to build a DR environment on Amazon Web Services platform. We typically approach these projects in 3 phases: an assess phase, a pilot phase, and an adopt phase. And specifically for running DR for Oracle eBusiness, we are offering a complimentary assessment phase, and then as you're interested to engage with us, we can also demonstrate a pilot phase of running eBusiness for your test environment, test eBusiness environment. And based on the success of the pilot, we can also help build the actual production environment for you based on your requirements. So with this, I'm going to pass this back to Sherry, and would welcome your questions, and we'll take the next 10 to 15 minutes to answer them for you.
Great. Thank you, Saru, and thank you, Bruce, for a great overview of the Oracle solutions. Folks, if you've joined us kind of midstream, feel free to submit any questions in your browser, and we'll take a few that we've got in the queue. I'm going to point this first one back to you, Saru. This is a question around licensing. As you were talking to one of your slides, the gentleman asked, so if a primary needs 8 Oracle license and a standby needs 2, can I change the same standby to 8 Oracle license if that becomes the new primary? So can you speak to that specifically?
Sure, Sherry. Yeah, this is Saru again. So the licensing question, it is best to look at each individual requirement and understand, and also work with Oracle as to how you are deploying, leveraging the existing environment and how it could be a good fit. I'm afraid a generic answer may not do justice to this, but as I had described in the slide, I think the AWS platform provides a great way of giving you some relief for licensing considerations, given the fact that the DR environment can be provisioned with much smaller cores, a much smaller number of cores, to just handle a standby environment and leverage your production licensing when you do have a true DR, when you have to fail over. So I hope that was helpful.
This is Bruce as well. Let me add on to that. And I believe that you are allowed to run a certain amount of hours from a DR site every year with the licenses. You'll have to check with Oracle on that, but unless you're going to be using that backup site for a long time, you may be covered on the licenses. So do check with Oracle on that.
Great. So the next question is, do you use Oracle DB installed on EC2 instances or RDS Oracle instances in your deployments?
I'll take that one, Shori. The Oracle RDS is a fantastic product from Amazon Web Services. However, it is not a good fit for Oracle eBusiness at this time. Oracle eBusiness requires a certain level of access and full ownership pretty much of the database engine in order to be able to do all of the various maintenance functions and AD patch and AD admin and various things like that. Whereas Oracle RDS provides a lot of those capabilities around backups and DR and replication and availability of the system, and that some of those full ownership is not available for the database. So therefore, for Oracle eBusiness, you will be running on standard EC2 instances, by installing and running or cloning your own Oracle database and application stack.
Okay, great. Next question, and I'll point this back to you, Thuru, and Bruce, feel free to chime in. The question is, do you have a solution for replicating the OS of physical database nodes to virtual machines at AWS?
Let me start off at a high level. We do have a way of obviously being able to replicate between a physical on-prem machine to a virtual machine using things such as DataGuard. Typically what we'd do is we'd have the same operating system running at both the physical location as well as the location up in the cloud for the disaster recovery site. So Thuru, do you have anything else to add or to build on that?
That's it, Bruce. Nothing specific to add there.
Okay, great. Somebody also asked us for what is the URL for the lab again. aws.amazon.com/test drive will take you to the test drive program, then click on the Oracle icon.
Great. And next question, Thuru, I'll point back to you as well, is how do you upgrade to the eBusiness Suite production environment?
Yeah, that's a good question. So the changes to the primary eBusiness environment are captured in the archive redo logs and are being sent over to the DR site, and they're being applied, and the database is being kept in sync. There's going to be certain times during your typical eBusiness cycle where you're going through a large upgrade process, or perhaps even a database upgrade. So you have to evaluate them on a case-by-case basis. For most of the standard patching activities, the database changes will propagate, and the application binary changes will also propagate through rsync or other means. So we don't have to necessarily do anything to your DR environment. But for those large upgrades or even database upgrades, a typical consideration would be to stop the DR synchronization and rebuild it after your upgrade is complete, and then reestablish the synchronization.
Okay, great. Follow-on question. Bruce, I'll point this to you, and Thuru, feel free to weigh in as well. Does AWS have any built-in capabilities to monitor the health of DR solution and automate the failover or fallback processes?
Yeah, because this is Oracle specific, I think I'll point back over to Thuru on how that works.
Sure, Bruce. Yeah. So there are several monitoring capabilities within the CloudWatch program that AWS has, where you can see the health of the environment and you can build alerts, and generally look at the operation of the server and storage and network layers. When it comes to Oracle, quite often corporations, companies will extend their in-house monitoring tools that are already monitoring your primary environments over the site-to-site tunnel or the MPLS line that may have, because the DR site is going to be a simple extension of a corporate network. It would be a network segment that has been chosen by working with your own IT team. So you would have full access over the VPN tunnel or the network, or whichever network connectivity you may have. So you're able to extend your monitoring directly to the standby environment and alert the respective administrative team that you may have. Our apps associates, as we provide for some of our customers, we can provide that service and capability to some of our customers by integrating with their administrative team very effectively. In terms of an automated way to activate and run the platform, AWS doesn't offer a package solution. Each customer's environment is different. Considerations are different. eBusiness Suite often is sort of a hub of several different integrations with various other applications and data feeds and integrations and data warehouses and things like that. So the process of failing over and activating a DR and failing back is unique for every customer. It's got to be looked at that way, and a process built around that.
Great, and that's an expertise you bring. So the next question, Cyril, I'm going to point back to you as well, is can you speak to what storage do you use for the database or app code tree?
There are several storage solutions available within the EC2 framework. EBS or Elastic Block Storage is what is commonly used. However, database requires certain I/O characteristics, especially transaction database such as Oracle eBusiness Suite. So there are specific solutions that are available in the AWS Infrastructure framework around the provisioned IOPS that can provide you those I/O requirements that a database would require. And this is where the various partners that AWS has would be able to work with you to design and build the correct architecture that suits your eBusiness environment and its characteristics.
Okay, great. Next question, and folks, we've got time for just a few more questions, so we appreciate you submitting. If we don't get to your questions, please know that we will follow up with you offline. Next question through is, does DR on AWS work if our production environment runs on Oracle Sun hardware?
Pretty much all of the cloud computing environments that are offered by most vendors in the mainstream are x86 based. So therefore, you are able to run various Linux flavors, Windows, proprietary operating systems such as Solaris, Spark, or AIX, HPUX, things like that. Those specific vendors may have perhaps cloud solutions for on-demand infrastructure, but specifically within AWS and others, you're looking at x86, so it's Linux flavors and Windows.
Okay, great. And Cyril, can you speak to the next question is, can I use the DR environment to offload reporting?
That's actually an excellent use case for the smaller the investment that may be that you're investing in a DR environment, but to be able to leverage that for reporting is an excellent use case. In one of the slides that I had illustrated earlier that showed how you can use the DR environment to build test dev environments, and that can be used for reporting, or we can have the DR environment open for reporting on a daily basis, say 7 a.m. It opens up for reporting in read-write mode and stays open till 7 p.m. And then it's taken down and synchronized with the logs that have been accumulating during the day, and then is ready to be opened up again in the morning for reporting. So this is a classic scenario where one-day-old data is acceptable for the concurrency of the data production environment, and these kinds of solutions are pretty powerful. There's also a way to use Active Data Guard, and that requires, of course, certain additional investment in licensing. But you can also leverage Active Data Guard that allows the database to be open and therefore continuous reporting as well. And these solutions are often pretty effective in offloading your reporting workloads from your primary environment.
Okay, great. And a follow-on question is, can I use this for populating my data warehouse? Like, for an example, would be run ETL loads onto AWS?
Yes. In fact, we have an interesting story there as well, is that a customer deployed OBIA, Data Warehousing Platform, on the AWS infrastructure, and they had the production EBS environment internally, and they were able to leverage the ETLs and execute them across over the WAN, right, over the wire. And they also were looking at reducing some of the time frame that was taking for some of the ETL runs, especially full loads that they needed to run. And we were able to achieve that by leveraging the DR environment, and similar to the reporting workloads, leverage the DR database, which is a copy of a primary up to a few minutes ago, and use that as the source for ETLs for populating your data marts and data warehouses. So the use cases, as every DBA or system administrator who is currently maintaining the EBS environments very well understands, by looking at this solution, I think they're going to see that they're going to find several different ways of applying the AWS infrastructure for many requirements for infrastructure around Oracle eBusiness.
Great. Well, I'd like to thank you, Saru, and for being not only a great partner, but providing us with a great overview of Oracle solutions on AWS today, as well as Bruce Burns. On behalf of all of us here, I'd like to thank you and invite you to just, before you drop off today's webcast, please take a moment to just give us a piece of feedback of how this webinar went for you today. If there's some questions we can follow up with, we will be happy to do that offline. And so on behalf of AWS, I'd like to thank you for joining, and this concludes today's webcast.